So our job is to determine what the limit is when x approaches 2 of f of x. So let's go ahead and get a graph of what this piecewise function looks like. So remember, when x is not 2, it takes on this top graph right here, the absolute value of x minus 1. And so that graph looks like a V. It's shifted to the right by 1 unit because of this minus 1. So if this is 1, if this at a height of 1 as well. Here's 2, so on and so forth. This is going to look like this. So this green one right here is the absolute value of x minus 1. However, it's not defined at 2. When x is 2, we get a value, a function value out of 5. Okay, so this is this one right here. And when x is 2, add 2, 2 gets plugged in here and we get 5 out. So instead of being at a height of 1, we're going to be way up here at a height of 5. So let's extend this line up. So here's our graph. What's in the green here plus this piece in blue. Now the question is, what's the limit as x approaches 2? So let's take a look at our graph. What we want to know is as we get closer and closer to 2 from both directions, what are our function values approaching? So our function values are height values. So I'll write this out. As x approaches 2, what does f of x approach? That's the question. And so if you notice, here, as I come in from the left side, I get closer and closer to a height of 1. And as I come in from the right side, I also get closer and closer to a height of 1. So what we would say is, the limit as x approaches 2 of f of x is equal to 1. It doesn't matter that f of x, so let's note this. Note that f at 2 is not equal to 1. So the function, because it's equal to, because f at 2 actually is equal to 5. So even though the function evaluated at 2 is equal to 5, the limit is equal to 1. That's the value that we're approaching from both sides.